our guest speaker, most welcome guest speaker today. And actually, Shoshanna, I never asked you how to pronounce your last name. I always say Saxe.
Saxe.
Saxe, okay.
Like saxophone.
Okay. Shoshanna Saxe, and I've been mispronouncing it on YouTube for the last 5 years, who is assistant professor in the Department of Civil and Mineral Engineering at the University of Toronto. I've always been intrigued by her work and really welcome this chance to have you out here today. Shoshanna investigates the relationship between the infrastructure we build and the society we create to identify opportunities and pathways to better align infrastructure provision with sustainability. And I'm not going to go beyond that because you got a lot more to say about that. So most welcome.
Thank you for having me. Thank you everybody for coming out, even though I just learned it's mandatory, but thank you for being here. It's a nice excuse to be in California for a couple of days in the middle of the Canadian winter.
Stop stealing all our rain.
We want snow. It's been very wet. We're also having a weird winter. So as you just heard, in my research group, we asked questions about infrastructure. Basically, is what we're building aligning with our long-term goals as a society? And if not, how are we falling short and where are our opportunities to do better? I happen to think that thinking about infrastructure is the most interesting thing I could possibly do with my time. Some people think that's pretty strange. And this is an example of popular culture thinking is pretty strange. In 2015, Last Week Tonight did a long stint about why infrastructure is important and why nobody pays any attention to it and why that's a bad thing. So I did a fake quote from the New York Times: infrastructure, something I've never thought about, but yeah, sure. Infrastructure, if anything exciting happens, we've done it wrong. And this fits into a general framework of it's hard to think about infrastructure for a bunch of things, for a bunch of reasons. This is a figure from the 1972 Limits to Growth, which was one of the first big sort of public intellectual works to say, we can't keep growing, we're going to run out of resources, and that's probably a bad thing. It's an early part of the history of the discussion about climate change and some of the issues we're facing now. But what they're showing in this graph is on this axis is time. So next week, next year, lifetime, or children's lifetime. And this axis is space. So our family, our neighborhood, our country, and the world. And what the dots represent is people who have the capacity or the ability or the privilege to think about problems at a certain scale. So most of us have time and capacity to think about problems that interface us and our family this week. But very few people have time or capacity to think about problems that are going to come to face the world in our children's lifetime. And this is part of the reason why we have such a hard time doing anything about climate change, but it's also part of the reason why we tend, as a general populace, to be mostly crap in the way we think about infrastructure, because a lot of infrastructure decisions exist here with impacts in between our lifetime and our children's lifetime. And up there in between our city and our nation, and now with climate change and international trade, globalization, much more even at the global scale. And most of us are just not equipped to do that. And we want to make decisions based on our own personal needs in very short timelines, and that's inherently incompatible with infrastructure. So the questions of how do we think about infrastructure in terms of time and space, and specifically transportation infrastructure, and how this guides what we might value and therefore what we might build is going to be the focus of what I talk about today. And so specifically, as we design and build infrastructure, what are the things that we should value? And what differences would it make? If we're assigning value, for instance, just to speed, we'll make very different decisions than if we're assigning value to air quality or the environment. But why should you care? Like I already said, I think infrastructure is the most interesting space that I can spend my time in, but lots of people think that's pretty weird. So one of the things is we spend a massive amount of money on infrastructure. This is from a list of the largest projects currently under construction in Canada. I couldn't find an equivalent list for California, so you'll have to fill me in on the blanks. And the numbers are out of 100 in the country where these infrastructure projects sit in terms of size. And these are just the transportation infrastructure projects just in the province where I live, Ontario, which is like, it's the equivalent of a state. And so on this list is $33 billion of infrastructure spend. That's a massive amount of money, and that's just what we're spending right now in one part of the country on just transportation infrastructure. So if we care about how our money is used, if we care about efficient use of taxation, we have to care about transportation infrastructure because it's one of the biggest things our government spends its money on. If we care about the planet, we have to care about transportation infrastructure, air quality emissions, greenhouse gas, preservation of natural land, ecosystem services. All of this is heavily impacted by transportation. And so if we look at some of the global numbers, we can see that a huge amount of global emissions are coming from transportation, and that's mostly dominated by single vehicle automobile travel with a combustion engine. And the reason that we live in this world where the vast majority of movement, especially in North America, is going on in automobiles and combustion engines is largely a reflection of infrastructure choices we made through the 20th century. And another reason to care is that everyone has lived experience of transportation. You all got here one way. I've already heard Professor Kendall complain about her need to drive here today and how annoying that was. I'm sure other people have experiences. It took me 4 hours yesterday to get here from San Francisco. I've already complained today about how annoying that was. We all have lived experience, and so we all have opinions about it, even if we're not researchers who do this full time. I don't know if this happens to you at parties, but anytime I go to a social event, people want to talk to me about transportation because they have strong feelings about it, and when they find out that's what I do for work, that ends up being what we talk about for the rest of the party. This is a real picture of real people protesting the bike lane, because they felt that this bike lane was really going to personally negatively impact their life. And they were very much focused in their life this week, my family, and the way it was negatively going to impact them, and much less focused on global scale and their children's lifetime. Okay. So let's talk about the boundaries that we usually use. And by we, I don't mean this room, I mean the way North American society has been making decisions about infrastructure for the last 120, 130 years. And our number one focus has been on mobility. We have a goal that we should all be moving as much as possible. And when you express it that way, it's kind of a silly goal, because of course we're not all trying to zip around in cars full time as quickly as possible. We're trying to get to the places we need to go. But a really good proxy measure for that is how fast is somebody moving. If someone's moving fast, they must be getting where they need to go efficiently. And so from this arose the analogy of transportation as a system of arteries, and when there's congestion, those arteries are plugged, and you need to free them up. And while in the transportation community, especially the academic community, we think that that analogy is false, it still widely plays out in our politics and in our press. So this is some press from where I live, Ontario on the top, and some could quickly find from California this morning, and just a lot of discussion about how highways are congested. We need to make more space for the highways so that they will be less congested. And the illogical, logical conclusion of that approach is something that looks like this. This is a real highway in China. I counted the lanes and got about 50. And it's a 50-lane wide highway in a traffic jam. Because you cannot build your way out of traffic. It's like gas, it expands to fill the space. All things that you've probably heard a million times as people who study transportation, but a knowledge base that has not made it into our decision-making structure in meaningful ways in much of the world. And the focus on moving people around, on movement itself being a good thing, is not just language that we see for cars and for roads. It's also something we see in our public transit authorities and anyone promoting any kind of transportation, because we've so internalized that this is the boundary we need to care about. Movement is the goal, that we use it as a proxy for good in all of the ways we talk about transportation. So this is Metrolinx, which is the regional transit planner where I live. And this is their front page. We need to build more public transit because we need to get people moving. So they've totally bought into the language. The transportation community has been arguing for a long time that's not a functional way to evaluate things. We need to talk about place and meeting your needs and getting where we need to go, not just movement itself. So within transportation, there's large discussions on accessibility, which I assume most of the room are probably familiar with, but the idea of your transportation needs to be not just about moving, but also about getting you where you need to go. And so if the things you need to get to are closer by, then you don't have to go as far, you don't need as much movement, you just need access. Again, this has been around for a long time, and it is many people would argue a better way to talk about things than movement, but it leaves out a lot of externalities, a lot of things about the environment, some of the impacts of construction, some of the questions of maintaining your infrastructure, what happens in the long term. And so there are all kinds of other ways of looking at our infrastructure, one of which is environmental life cycle assessment. So standard environmental life cycle assessment for the built environment is you look at the materials you need to build your infrastructure, getting into site, doing the actual construction, and then operation, repair, and replacement in a fairly narrow space. I would point out this could be 100 years, but it's quite small. And then at the end of life, you have to demolish it. And if you look at all of these things at once, you'll have done a holistic assessment, is the generalized argument. And there's a lot of academic work looking at this. I've done some, lots of it has come out of UC Davis. There's a lot of really valuable academic work. But as we know with most life cycle assessments, the answer is always, it depends. The numbers are always fuzzy. It depends on your boundaries choice, both spatial and temporal. And while we could live with that uncertainty fairly comfortably when this was an academic exercise, and even in 2008, which is not that long ago, when some of the sort of fundamental LCA for transportation papers started coming out, it was really just the academic community that cared. But that has changed really rapidly recently, and we've seen an increasing amount of legislation calling for life cycle assessment of infrastructure to make decisions. So apologies, none of these are American, but this was a requirement in my province to have life cycle assessment for every single large infrastructure project by 2019. That government lost the election, so it didn't happen. It is happening in BC, it is happening in the UK. We also see national level requirements and funding. So you have in the States, FHWA is involved in life cycle assessments. This is a federal requirement to do life cycle assessment if you want funding for certain kinds of projects in Canada. There are examples like this from all over the world. And on one level, it's really exciting because it's a much broader way of looking at the problem. But on another level, we have stretched past its function a tool that was originally designed for a famous soda brand, as a reviewer told me to refer to this company when I specified it in a paper. So it was originally designed for a famous soda brand and consumer products, and we've expanded it since then to bigger and bigger systems. But life cycle assessment is widely known to struggle with things that last for a long time, struggle with things that are big, struggle with things that have large consequential impacts, all of which apply to infrastructure, and they apply to an infrastructure at a scale, I would argue, more than almost anything else humans manufacture. And this leads us to a challenge because we want to use life cycle assessment. It's a very powerful, holistic way of thinking. It gave us a new way in that we'd never had before. It was a huge improvement over, let's think about transportation just for mobility. And decision makers and people writing legislation and people making the legislation real, they want a tool that they can use. This is the question I get asked the most by members of government or by people in construction agencies: what tool should we use? And even with life cycle assessment, it's hard enough to make a tool. But if I'm arguing that life cycle assessment itself is not great, what tool does that leave them with? So I'm going to come back to that question. But in the meantime, I'm going to make a case for what's going on with life cycle assessment of transportation infrastructure and why it's so much more complicated than what fits into ISO standard LCA. So first off, there's the question of mobility. So we're back to thinking about movement. Your choices for what mobility you can make really depend on what's available. So this campus, from my few hours here, seems to have a lot of biking support. So it feels like here it's really easy to choose to bike. How many people in the room biked here today? Okay. So at a North American scale, the mode share in this room is off the charts biking, right? Most places biking is under 2%, but in this university, there's real opportunity to bike. So you're able to make that choice. I found out after driving 4 hours that it is actually kind of easy to get here by train. So next time I come, I will make that choice. But it really depends on what's available. Then there's the background systems we have to worry about. This is classic life cycle assessment stuff of what's the energy that's going into moving our propulsion system. So if it's a combustion engine, we have to worry about the impact of the fuel. If it's electricity, we have to worry about how the electricity is being made. And this is the greenhouse gas intensity of the electricity in Ontario where I live. It's global scale low. You often see numbers over 100, China's in the thousands. We have exceptionally low greenhouse gas electricity in Ontario, which means that, and from a life cycle perspective, almost anything we run on electricity is going to win. But that will change from place to place. Then we have to start dealing with that operation phase, which was more or less a very small section of the life cycle assessment figure. in transportation where a lot of things start to get really complicated. So there's a classic thing of induced demand, which is, again, a well understood transportation phenomenon, but not one that is all that well managed or understood within our policymaking design framework, which is the more capacity that you provide for transportation, most famously in terms of highways, the more people will drive, which is why the illogical conclusion of expanding highway is an even bigger highway with just as much congestion, because as you make it easier to drive, more people make the choice to drive. The nice thing about induced demand for transportation is that it works not just for automobiles, it also works definitely for bicycles. We tend to see increases in bike ridership, orders of magnitude above what was predicted whenever good new bike lanes go in. I love this classic drawing, which is the one guy on the tightrope, which is like, this isn't so bad, and everyone else going, no way I'm biking over that. And then the bridge, and the person on the tightrope is like, yeah, I'm okay with this, and everyone else is like, oh great, now I can bike. So this starts to make it a little bit more complicated, but people have dealt with this within lifecycle assessment. Then we can go back to the beginning. We talk about, okay, if we're going to be measuring something over its whole life cycle, we need to understand what's happening in the beginning, in the construction. How much resources and material are we using to make the product? And this is really important because we use orders of magnitude more material to build elevated highway or an elevated rail line than we do to use something at grade. It's much more materials, again, if we build underground. So we have to take the materials really seriously, especially because for the first 10 years of any infrastructure project, it's basically just going to be cost in terms of the environment from construction. And if we want to have impact by 2030, well, that's all we're going to be doing between now and 2030. And if we want to have impact by 2050, our window to pay back the construction is fairly low. So we've done some work in my group looking at, okay, well, how can we understand the materials in construction? These are figures looking at the granular material, so basically the aggregate under the road, the concrete and the asphalt used in all of the roads in the city of Toronto. And what we found is that it's hugely variable across the city because of our historic political boundaries. So you can see almost perfectly in this figure that Toronto used to be made up of 5 different cities that were put together, and they each had 5 different standards. And so we had much more granular in these 2 parts of the city than we did. And also this one, which is concrete, you can guess where in the city we have flexible pavement and where in the city we do not. Downtown, we put concrete on our roads. The rest of the city, we tended not to. And this type of thing makes it very hard to get an overall understanding of what's going into our materials because it varies a lot by place to place. This is a small sample. Varies a lot of place by place based on history, based on construction codes, based on weather, based on maintenance cycles. And that's the whole city. We also looked a little bit at a specific project. So this is one bridge project. We wanted to know how good a job are we doing within life cycle assessment at understanding the upfront construction material impacts. And we had 3 different sets of data for the same bridge that looked at the embodied greenhouse gas impact from its construction. So this is what we call the base case, which is from the building information model, which is what the general contractor had provided to have a 3D representation of the construction. This is just the materials that were included in the building information model, but if we adjusted the count of materials from what was predicted to what was actually used on site. So you can see there's huge increases in concrete as well as in asphalt, which is the top one. And then the building information model didn't have things that aren't in the building information model. So in most building information models, you don't draw rebar in the concrete because it's really painful and no one would go to all that effort. And also, you know where the rebar is, it's inside the concrete, so you don't have to worry about it being in unexpected places. So we added the rebar, and then most building information models don't have anything on construction equipment or construction energy. A bridge, like almost anything built on the ground or below the ground, is a huge amount of construction energy. And so we had a big increase in the top bar, which is fuel. So if you look at these numbers from what we would have predicted, about 1 times 10 to the 6, to what we actually measured, which was closer to 4 times 10 to the 6, we've had a 300% increase in the expected greenhouse gas emissions on the bridge just from collecting the data in a slightly different way. So this is another big problem for understanding life cycle assessment of construction projects is that you don't know very much about them before you build them, and by the time you build them, they're already built. Then we can go through another standard part of the process, which is looking at maintenance. The lifespan of a construction product, especially transportation infrastructure, is very long and has a lot of maintenance. So this is a case study we did of a dedicated streetcar route in the city where they built the right-of-way, of how the materials went over time. And we found that they originally started construction in 1987, and we stopped our study in 2018, but we had predictions of maintenance through 2025 based on the schedule of our transit authority of what their maintenance plans were. And that we found between 1987 and 2025, they were going to completely rebuild almost all of the right-of-way, which meant that the initial upfront impact was doubled within about 30 years. If we're talking about payback periods for infrastructure of 10, 15 years, then a huge amount of the time taken up to pay back the maintenance was going to mean it wasn't returning greenhouse gas emissions. Not to say we shouldn't have built this, but part of the reason it needed so much construction was that it was built quickly the first time, because they wanted to keep the number of days they kept the road shut to a minimum. And so it turned out the sub-base, which they had expected would survive much longer than it did, had to be completely rebuilt at their first refurbishment, which meant that the closure was much longer the second time and it had way more materials. Okay. Then now we start to get into things which are sometimes included in transportation life cycle assessments and sometimes not, which is the very well-established relationship in between transport and land use. Based on the transport that you build, you heavily influence the type of land use behavior that goes around it. So if you don't build a highway, you're very unlikely to end up with a suburb, because there'll be nowhere for the people who would live in that suburb to get into the city. You can't have suburbs without highways. You very rarely have highways without suburbs. And so these are some famous literature online in the field looking at the relationship in between transportation infrastructure and the expansion of urban space. And so this one is saying, how big were cities dependent on their dominant structure of transportation? So when everyone was walking, cities were fairly small. As you move to streetcar suburbs, you got bigger cities. As you move to the car, you got much bigger cities. And there's a famous feedback loop in between. You provide transportation, there's demand for land use. As soon as people are using the land, there's a demand for more transportation. You provide more transportation, there's more demand for land use. And this repetitive cyclical process, which means that if we evaluate our transportation system without also evaluating the land use system that goes with it, we're going to miss a big part of the story. And again, this is very common in government, is that you have one department, the Ministry of Transportation, and another department that looks at land use. For me, that's the Ministry of Municipal Affairs. I'm not sure what it's called in California. But the planning department, local.
Here it's local, there is no state agency, really.
Okay, so even worse, it's two totally different levels of government. So there often is a big issue in coordination between the two. And so if we want to make life cycle assessment transition from something academic to something where we can make policy around, that becomes a big problem to bridge, first intellectually, because we have to tell people that they care, and then practically because of the distribution of responsibility and power. And another thing to take into account when we're thinking about land use is what it means for our natural systems as our land use spreads. So again, this is the city of Toronto, this is where I'm from, and the darker red the area, it's when it was first built up. So this is from 1850 to 1915. Yellow is from 1916 to 1945, and blue towards green is the post-war period, where we had big expansion of highways and suburbs. So you can see that the downtown area was all built up pre-war. But after that, there was a rapid expansion into what had previously been farmland and natural land. And this is just showing the city of Toronto. Since 1960, most of the development has been outside the city, in what was in 1945 would have been really far away. But now our region has about 3 million people in this city and another 3 million people surrounding it in the historic suburbs. That means there has been a massive translation of what was historically farmland, which we need for food, natural land, which we need for ecosystem services, which is now covered in built up land. And that was completely facilitated by our choice of a transportation infrastructure at the time, which was to build lots of highways and to have lots of cars. Okay, so That's already, I think, a fairly complicated picture, but when we're thinking about transportation infrastructure, it gets even more complicated. So one, just to highlight we don't really know what we built until we built it. This is, again, one of my favorite cartoons. It's a joke about construction management. So there's how the customer explained it, how the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how the project was documented. This is a big problem for lifecycle assessment. What operations installed, how the customer was billed, how it was supported, and what the customer really wanted. And this variation of expectations and who's in charge of what, the lack of records, the lack of decisions, and the big difference in between what we think we're getting and what we actually get, which is somewhere over here, is a fundamental upfront challenge with understanding transportation infrastructure. Then there's some more conceptual challenges, which is that lifecycle assessment is set up for products that end of life, right? So our drink bottles or our cell phones will end of life in a time period that we understand. I've had my cell phone a long time. I've had it for 3 years. Our water bottles exist in our life probably for a few minutes to 2 years, depending on which kind of consumer product we're using. But our transportation infrastructure exists well beyond our own life. So these are two extreme examples. This is the oldest bridge in the world, still in its original condition. It's from 62 BCE, it's more than 2,000 years old. And the London Underground, which is more than 150 years old. These are products that are operating not that different from how they were originally designed, but with a temporal scale that we are completely incapable of managing. I think we'd say potentially within our puny human brains, but definitely within lifecycle assessment, which was not set up for products that last this long. Right? Lifecycle assessment struggles after 10 years, really. Then we get to some sort of thorny philosophical questions. So is anyone here familiar with the ship of Theseus? Okay, so for everyone else, I'll go through it. Theseus is a famous sailor. He dies. In year 0, we have his boat. Theseus was famous, so we want to keep his boat. It's made out of 1,000 boards, but over time they rot. So in year 1, one board rots, and we take it off and we replace it. And now we have the ship that has 999 of the original boards and 1 new board. Is it still Theseus' ship? I'm gonna take a vote. Yes? Anybody vote no? Okay, so we do this once a year. In year 500, it's 500 new boards and 500 of the original boards. Is it still Theseus' ship? Yeah. Okay. At the end, we've got 999 new boards and 1 board, though the oldest of the 999 boards has been there for 998 years. Is it still Theseus' ship? Yes. So now we've got some people saying no and some people saying yes. And most people make the transition somewhere in between, or at least start to feel kind of uncomfortable. At some point, oh, I don't know, when it's 998, that's clearly still Theseus' ship. When it's 5, I'm really not sure. This is a famous philosophical question. But we exist in this space all the time with transportation infrastructure because we're constantly taking it apart and putting it back together. We patch part of the road. Maybe we replace an entire bridge on the highway system. We shut down the tunnel and reconstruct it. And so because of this, we traditionally do in lifecycle assessment, we say it has an end of life. And so we'll say it has a 30-year service life, or it has a 50-year service life, or maybe we'll go wild and say it's going to be around for 80 years. But we're saying that the product, once it has 999 new boards, is a fundamentally different product, even though it's serving the same purpose in the same space that it had before. And many times we're following the same logic that was already there. So for instance, where I live in Toronto, we have an elevated highway downtown. We would never build that now, but we already have it. So we're about to spend billions and billions of dollars refurbishing it because it's sloughing concrete onto the road underneath, and that's bad. So we're going to refurbish it. It's going to cost about half of our maintenance budget for this foreseeable future. Right? We would never put ourselves in this situation now, but we're committed to decisions we made in our infrastructure system 50 years ago. To belabor the point a bit, the impacts of our decisions, even if we rebuild the physical infrastructure, even if the concrete has changed, last for a really long time. So these are some recent work which I love. This one, Roman Roads to Prosperity, which came out 2 years ago, was looking at how where the Romans built roads is still predictive of prosperity in Europe. So that's an infrastructure decision that was made a long time ago, which is still having major consequences. This work looked at the echoes of transportation and land use policy through time and found that even when the policies were stopped, 20 years later or longer, you could still see the echo of those policy choices, of the infrastructure policy choices in what was going on. This was in the Netherlands. And we see this, we know this in our real life, that it's very hard to undo a choice about infrastructure, which makes the original choice much more fraught. So this is a road through a forest. There's research from all over the world that once you put in even temporary roads in a forest, you can't take it back. Partially, there becomes a lot of pressure to make the road permanent because the people who are using it like it. But also, you introduce a new physical pathway through the forest, which non-humans use as well. Species migrate, plants migrate, and even if nothing else happens, it takes a very long time for the forest to heal. And so, even if you said we're just making a temporary road for 2 years, the impact goes much, much longer than that. And because of the land use implications, so this is a picture of where the original subway line is in Toronto. There's very high density built around our subway nodes, in part because of historic policy, but because the subway was there. Even if we shut the subway down now, we would not be able to undo the land use that went with it. And this works for the better and for the worst. American cities that had more streetcars in 1910 are more walkable now, which is great. The streetcars are long gone, but they're still more walkable. But at the same time, once we've put in highways and subdivisions, which lead to more consumption and more pollution, it's very, very hard to take that away. So another thing that makes it more complex is the network effect. There is a huge bias within our transportation infrastructure to whatever it is we've already built. So the first new bike lane in the city, for instance, has almost no value because it's not going to connect anywhere. No one's going to decide to ride their bike because there's 500 meters of bike lanes on one downtown street. This is a picture of the cycling network in Toronto, and the dominant experience you should get from looking at this is that it's not very connected. But at some point, you get to a step change in the infrastructure, or if you have a minimum network, the 100th kilometer starts to have a lot more value than the first one because it takes advantage of all of the other kilometers it's attached to. It's the same thing with the dominant infrastructure system. A new access road built to a place is going to be immediately useful because of every other road it's connected to. So if we build 100 new homes and provide them with a road that connects to the highway system, they can go anywhere. If we build 100 new homes and connect them with a subway station, and the subway doesn't connect to anything, it's completely useless. Which, that bias built into our assessment, it always means that we're going to undervalue the thing that is new. So if we're in a place that is dominated by roads and we want to switch to something else, our ridership predictions, our mode share predictions are all going to find that it's majorly underperforming. And it means that you either have to invest in a very big system all at once, which we find politically, financially, emotionally hard to do, or we have to find a way to do the assessment that gets rid of the bias built in against anything new. And then finally, there's the complication that infrastructure comes first. So we often want to predict what the future will be like and say, this is the future that is coming, and build the infrastructure to line up with whatever our expectations of the future are. But the causal effect is reversed. Historically, as I'm about to explain in these graphs, we build the infrastructure and the future manifests on top of it. So this is a great paper, unfortunately not mine, but I strongly recommend, of looking at what came first. And so for trains, we built the track mileage long before people invested in the locomotives. What was the point of driving a train if there was nowhere to drive it? And only afterwards, where there were lots of trains and lots of tracks, did people start traveling by train. Similarly, for automobiles, first came pipelines to move the oil, then came the roads, a big delay in between the roads and registered automobiles, and then once people had automobiles, they were like, oh great, now I can drive everywhere. And I think this is really important because we are hearing people deliver the future to us to try and get us to build it for them. Right? So people say things all the time like the future is autonomous, but I need you to change the way you're building cities and I need you to invest in all these things and then the future will be autonomous. And so this causal relationship is really important and often ignored. And if we're going to do assessment based on something, we have to have what the counterfactual is. What are we comparing it to? Are we comparing it to a future where we build nothing, in which case that's a choice which will create a particular future? Or are we comparing it to some other future where we build more or less of this thing? And depending on the counterfactual we compare to, we will find very different results for our life cycle assessment or whatever type of assessment we want to do about our infrastructure. So then, as we're coming to design our infrastructure, there become carrier questions which engineers don't usually deal with. And this is what I like to call the moral infrastructure quandary. Are we building moral infrastructure? Is it morally justifiable to do what we're doing, given that as engineers and planners, I think mostly engineers, yes, we're wrestling a lot with building the physical world. So there's lots of different ways to frame morality. It can be the needs that we need today, but I think Kant did it in a really helpful way. And basically what this says is something is moral if you could live in a world where everybody was doing that thing. And it is immoral if you couldn't live in a world where everyone was doing that thing. So you can do a bunch of thought experiments. Could you live in a world where everyone wore orange all the time? Yeah, I mean, it would be weird, but fine. Could you live in a world where people went around punching each other in the face at 2:30 p.m.? No, that would be bad. It would be painful. So it is immoral to punch someone in the face at 2:30 p.m. for the fun of it, but it's fine to wear orange. Could you live in a world where cities build automobile-centric transportation for everybody? No, you really physically couldn't. The air pollution, the greenhouse gas emissions would be debilitating. The loss of natural land would be debilitating, but also it physically wouldn't work because if everyone is driving all the time, everyone is sitting in really bad traffic all the time. Which means that we have a real quandary about continuing to make these choices, which are very North American choices, because we couldn't live in a world that was like that, which according to Kant makes those immoral choices. So what am I proposing? I said there's all these different ways to think about infrastructure. I said that life cycle assessment was a big step up, but I think it's majorly flawed when it comes to these systems. So we have work and review, where we're saying this is one way you can think about it. You think about the original construction impacts, you think about resources, you think about the disruption of the construction, you think about how long it's going to take, you think about the direct operational impacts, which is everybody driving on the road, standard maintenance. Then you have to think very seriously about the induced impacts, which are your travel behavior, local land use, the networked effects, the broader land use change effects. And that you can't take end of life too seriously because most of the infrastructure isn't going to end of life. It's just going to return to a phase where you have to go through construction again. And this leads us to a bunch of questions that I can't necessarily answer, which is how many times should you be obligated to go through the cycle when you're assessing one project? I think probably more than one maintenance cycle, which is not how we usually do it in life cycle assessment of infrastructure at the moment. But do you have to take account of 500 years of impact all up front? I would argue that I think anything under 75 is too short, but that we'd be justified in stopping by 100 because the uncertainty just gets way too big. Other people might make different arguments, and I hope that once this comes out, people will engage with us and tell us the ways we were wrong and the ways we were right. Suggest other alternatives. But now for fun, let's think a little bit about what thinking about these problems differently would bring us to different conclusions. So I'm going to start with the autonomous car. There are a bunch of different narratives out there about the autonomous car and lots of excitement about it. One of which it would free up all of this capacity on the roads. It would allow people to have freedom of movement in a way that they hadn't before. It could decrease accidents, though we actually haven't seen that happen yet. But if we think about it from an induced demand perspective, if we think about it from a land use perspective, if we think about it from an infrastructure lock-in perspective, I would argue that autonomous cars start to become a fairly scary looking technology. Because cities and all of the problems with their expansion that came with the car will be on steroids with the autonomous car. We should expect much more of everything, much wider land use, much more conversion of farm and natural land to subdivisions. We'll need much more roads, which means more infrastructure construction. We'll need the sewers that go with them. We'll need more fire stations. We'll need more schools. And it's very hard to build all of that in a sustainable, financial, environmental, or social way. But we see lots of excitement about it. We're already being told that the autonomous future is coming no matter what. I think the first time I was promised the autonomous future in 5 years was 15 years ago. I'm sure the people in this room who heard that story earlier. But in the telling us that it's coming, they're getting a surprising number of people to line up and make it real. So cities bending over each other to say, come experiment here, we'll change the laws, we'll change what we need to do, we'll facilitate our infrastructure, so you will experiment and let us be at the cutting edge of autonomous. I read a government report, Canadian government report that said, in 10 years, all infrastructure will be smart. Which is ridiculous on many levels, including that we don't turn over infrastructure that quickly. But the expectation that this is coming is influencing us to build the infrastructure to make it inevitable. Then we can ask about the electric car, which on many levels is a huge improvement, right? The tailpipe emissions are much lower. If you're in a province like Ontario where the electricity is really clean, I don't know what the greenhouse gas count is in per kilowatt in California, but I think it's pretty good.
It's all right.
Yeah. It's better, you guys aren't running coal the way China is. Then it's much better on a kilometer per kilometer basis. But when you start to think about the land use implications, about the induced demand implications, about the infrastructure lock-in implications, electric cars look less like a good solution that's going to save us and like something that's not as bad as the combustion engine, but still locks us into much of the same cultural and infrastructure challenges that we've been fighting for the last 100 years. So I assume you guys have seen this picture. Have you seen this one? So then we can look at other really revolutionary mobility technologies, like the bicycle and the scooter. This is not an electric scooter, it's a regular scooter. And while many people argue that the autonomous car, the electric car, anything car related is the technology of the 21st century, we should build the infrastructure to go with it, I would argue that increasingly, this is the technology of the 21st century, and we should build the infrastructure to go with it because the carrying capacity is higher, the induced demand impacts are positive, not negative, the land use impacts are really encouraging, the upfront material investment is much lower, and the risk of still having bike lanes 100 years from now is really not at all scary. So what does this all mean for cities? Because I remember I promised in my abstract that I would say, what happens when you scale up to cities? So here is a bunch of famous art from Jeff Boeing, where he did at exactly the same scale, the street network of different cities. And I would bet that you could guess just from looking at these, which ones would be a nice place to have a walk or sit in a cafe and have a drink. Does anyone want to pick one? Yeah. Right? What continent is this on?
Europe.
Yeah, it's Europe, right? The one at the top, what continent is that on?
The nation of Houston.
Or
China.
Yeah, it's North America. So just from looking, right, there's no context provided in these figures about these cities other than the shape of their streets and how much space between they dedicate of their city to streets. But already we can make all kinds of judgments about what type of city that is, whether or not it's a place where we want to spend time. We could probably guess what the real estate prices are comparatively between these pictures. We make lots and lots of judgments and understanding about what a city is based on its transportation infrastructure. And if I added to this the bike lane network or the public transit network, we would have even more information. Just to give you the names of the cities, so Mississauga is a suburb of Toronto. It's actually a really, really big city now, but it was all post-war, all automobile dependent. They're trying to change that, but one of the things they have to do is make their blocks smaller. This is Toronto, San Francisco, Rome was where we all wanted to have coffee. Our transportation infrastructure is the baseline. It's the skeletal structure on which our city is built, which means it's even more important that we get all of it right, and especially because we're going to have almost no chance to redo it once we've done it, and the impacts of it are going to last well beyond our lifetime into our children's lifetime. And for a lot of the big societal scales problems that we're trying to deal with, climate change, equity, costs of our services, the choices that we're making about transportation are really fundamental. Okay, so what does one do with all of these thinking? So one of the things that I did with this thinking was I wrote an op-ed in the summer in the New York Times arguing that technological approaches were taking us in the wrong direction. I think this is the most loudly received thing I've ever done. The academic paper that makes the same argument had a slightly smaller readership. And I got lots of pushback. One of my favorite was the top opinion. Engineer discovers ideas from urban planning and public administration, which I thought was a really good burn. And I put it up because I would encourage you to take those fields seriously. Urban planning and public administration have things to offer us. They're working at a scale of problem that I think engineers should be playing, but are often not, because we're interested in a very technical, how do you design this joint? How do you design this beam? What should be the curve of the pavement on this road? And I think we have a role to play at the levels of urban planning and public policy administration, so I think we should take them seriously. Also, a lot of urban planners I spend time with, they have a thing about engineers, which I don't fully understand, but I think it was a history of our own hubris about showing up with numbers and saying that this is the basis for decisions. It should all be quantitative, and we know better because we have numbers. Whether or not the numbers are the right numbers or whether or not they're accurate is a whole different question. And then of course I got pushback from people working in the smart city community. So what? Having said all of this about the way we think about transportation infrastructure and arguing that we need to think about it in different ways, what do I want to leave you with? So I think the main thing is a thought process, it's not a tool, which is in some ways really unsatisfying, because what the government wants from us is tools, and if you can have a checklist to go through, then you can make sure that you're hitting all of those things. But I think we have to be very careful about counting what matters as opposed to what can be counted. And lots of the things that we would put into traditional assessment, we focus on proxy measures because they're easy to count. And those are the things that can end up in our tools. And we need to be very careful about that. If we have narrow goals, we'll come up with narrow solutions, which goes with the second last one, which is we need to be very careful about the question. If we have a problem with congestion in our cities, it's very easy to say there isn't enough space on this highway for all of the cars. So our problem is there isn't enough space on the highway. How do we make more space for the cars? But that's because we asked a question about congestion. We could ask a question saying, why are all these people in their cars on the highway? Maybe we could have a different solution, in which case we might change one of our lanes into a dedicated bus lane or a dedicated HOV lane and try and get, instead of more vehicles, a more efficient use of vehicles. Then we could ask a question about, well, why are all of these people having to drive so far or go so far to get the things that they need? In which case we're asking a question about land use. It's the same problem, but we've come up with very different questions. And depending on how we define the boundaries of the problem, the temporal boundaries as well as the spatial ones, we'll ask different questions and come up with different solutions. So I'd say be very careful about spatial and temporal boundaries and start probably bigger than is traditional in our field and potentially that is our natural instinct. And another thing I would leave you with is, how do we make this a formal system? And we've come up with a figure. I think it's very pretty because it's circular and we use nice, got a graphic designer to make it look nice. But complicated qualitative as well as quantitative problems are very hard to fit into the formal systems. And it's very easy to brush them off as soft and not technical, which is something engineers don't like to hear. You tell engineers they're working on a soft problem, we'll say, no, I'm a real engineer, I deal with numbers, take it very seriously. And in a world that really values STEM, being accused of doing things like infrastructure philosophy can feel like you're being told you're doing something of less value, which also this permeates through to our governments and our policymakers who want to feel like they're doing something hardcore, just like we want to feel like we're delivering them with something hardcore. So that is it for me. I would hope that for at least some of you, it's a new way of thinking about boundaries in space and the way in which that would impact how we make decisions about infrastructure. And I think we have lots of time for questions. Yeah.
So when you talk about common systems of holistic thinking, do you also tie it to engineering education and how we teach undergrads, or when we start teaching engineering, particularly how we can incorporate all these ideas? Because largely, I mean, the entire society and all of the engineers, when they go out and do stuff, it's them who, when they do that holistic thinking in whatever field or whatever position they are in, they could think about all of this in a more holistic manner and, you know, quantify and make some performance measures that sort of are justified for the larger goal. So do you tie that link, and do you have any ideas on how to operationalize that?
So the question is, how do I think we could better do this within our education system?
Yeah, do you think even is engineering education an answer to this formal system for holistic thinking, or what are the practical ways where how we can implement this? Because if we were to go out and train government officials or people in position to make those decisions at different places, I mean, it looks like a very humongous task to me.
Okay, I'll try and take that in order. Yes, I think it is a big task, but start somewhere, take a step, and the task gets smaller. So I don't think we should be intimidated by big tasks. I think that's one of the great advantages of engineers, is I think we have a little bit of hubris about big tasks. Like, sure, we can dam that river, no problem. So I think we should not shy away from the big tasks. Yes, I think there is a role in engineering education to put more systems thinking in. I think there's already a movement. I mean, we both teach systems thinking classes. I think that we need to take more seriously within engineering education some of the traditional humanities. What would an ideal engineering education look like? I think it would include a philosophy class and a public policy class. We're already doing a lot of hard numerical things, and it can feel like there's no space within the education system for more. But I think that we should take those things seriously, and if you have the opportunity as students to expose yourself to that, I would take advantage of that opportunity, because the opportunity for learning in school is pretty unique. There is a movement to think more about what engineering education needs to be like. So there's 2 papers that I would recommend to you if you're interested in thinking about that. One is a 1970 paper written by a guy named Tribus in IEE Spectrum, which is talking about the engineer in public policy. He says the engineer enters the public policy sphere like a gladiator with one hand tied behind his back. And a more recent paper by Chester and Allenby called Infrastructure in the Anthropocene, which I think does a fairly robust teardown of the holes in our current education system. So there is an ongoing conversation. Personally, I bring this stuff into my graduate classes, so I hope that in the small way the people who train with me talk about it. Part of the original impetus for some of this work was a conversation I had with a bureaucrat while the province was thinking about building a mandatory life cycle assessment. And I was like, okay, this is great. As you're evaluating your roads, what are you doing about land use? And they're like, oh no, we scoped that out of the life cycle assessment. What are you doing about automobiles? And they said, no, we scoped that out of the life cycle assessment. And I was just like, you can't scope that out of the life cycle assessment. That's the whole point of transportation life cycle assessment. And they said it would be too political. And I didn't have anything to hand them to say they were doing it wrong. And so I thought I better write a paper so that we can say, you know, academic paper says it must be done this way. And I'm still in touch with that bureaucrat who's now left government. And I think he was slightly surprised that I was serious when I said that the paper was in many ways thanks to him. But I think that there's a role we can play in pushing the thinking forward. And in many fields, we have to hope that the thinking outside of academia will eventually be influenced by what we're doing inside academia.
In California, we have the California Environmental Quality Act that requires some environmental assessment of proposed projects. And I don't really know the time scale that's envisioned on that, but with what you're presenting, I'm really suspecting that it's too short a time scale to really give and I'm wondering you or anyone else has any insights on that.
I am not at all informed on environmental assessment rules in California. One of the big hits about environmental assessment globally is that you're assessing what's bad on projects that have already more or less gotten through the pipeline. And so it's an effort at mitigation as opposed to early stage, should we build this or that? And there's very rarely a no build consideration in environmental assessment. I don't know if California is different.
So that, I mean, I'm not super familiar with CEQA, but the project has pretty much gone through scoping, and you're usually either killing it through a lawsuit or you're tweaking it. But comparing big broad choices is not a part of that process.
Yeah, that's right. I will say though that I think some of the other policies in place, like SB 375 related policies, are trying to get at land use change, and there at least CEQA does include a requirement to think about things like induced demand or rebound effect. So they're supposed to include some of that, but I'm not sure what the timescales are.
So legislation has been passed. The issue, which I didn't realize in Ontario, is that land use is a provincial issue. Here it's a local issue or a regional issue. And that's the basic conflict, is state mandates, which are usually tied to money, flow through of money, but there is no state control of land use. It's really, except if they choose to build a highway here or there, to reduce, but it's really locally controlled. And therefore it's on your scale of who cares about what and for how long. But the time scale for all of that stuff is like tomorrow. It's not very long. Well, no, so we took a stab at this. We wrote the Federal Highways Pavement Lifecycle Assessment Framework, and I feel some of the critiques here, but I think we got a couple of things.
I haven't read that one.
Take a look. We tried, say, 4 years ago, first stab. But lifecycle-wise, we put the end of minimum analysis period is the first major reconstruction, not the first maintenance, not the first rehabilitation. It's the reconstruction, but then call out. At that point, we may only be dealing with 20 or 40% of what's there, because we're just, usually it does, like you said, it doesn't go away.
Yeah.
Parts of it get rebuilt and repurposed.
There's great disaster research on persistence that even cities that have been completely destroyed, like from a natural disaster or from carbon bombing in World War II, tended to build the exact same transportation infrastructure again. Like the persistence of our transportation infrastructure is impressive.
So I have two questions, one more numeric and one more philosophical. The numeric question I have is kind of on this this push and pull that I always feel when thinking about this, between trying to include more into sort of your holistic system analysis and the practical reality of statistical analysis of uncertainty. And the more you bring into a system, the more uncertainty you have. And at a certain point, I've always felt the amount of uncertainty can then render an analysis fundamentally meaningless because you don't actually know anything about anything because of how big uncertainty is. And I know we touched on this a little bit during the lunch conversation about the size of uncertainty bars in certain projects, but I don't know if you can comment on kind of resolving that push and pull as you expand the scope of how you think about these systems.
Yeah, I think that's a really fair question, though I would argue if we're making the boundaries so small so that we can have reasonable uncertainty, that's spurious. Right, it's not representative of the problem, but to a certain extent, we have to be able to analyze things, and we can't just say, oh, it's too complicated, we don't know. We have to put down an opinion. And I think that there's a couple different ways we could handle that. One, with broad scoping. You could think, for this type of project, how big are these influences likely to be, right? If we're replacing a bridge that's already there in a system that's otherwise the same, a lot of these are going to more or less fall out because most of those decisions are already locked in, and we can say, because of the scope of this project, which is within bounds of a system that already exists and is just replacing the bridge, probably we can say the land use impacts are going to be smaller, so on and so forth, and we can scope that out. If we're saying we're going to build a whole new highway or a whole new highway lane or 2 new subway lines, then I think we have to recognize that the scale of the impact is much bigger. And we have to say the impact of the land use change or the potential impact on preservation or not of farmland could be really determinative for this project, in which case we have to do some kind of analysis. And I think that given there's so many unknowns, a lot of the time what we should be looking at is scenario analysis just to bound the problem and try and get a sense of what potential drivers are flipping us from a build to no build scenario or from an A to B choice. And that many of the times that will be, excuse me, the best that we can do of saying what we want to know is what are the important things that flip us between one choice and another. And once we can identify what the important choices are, we can start paying more attention to them or start mitigating for that problem or put supportive legislation in around the infrastructure project, right? This project will only be viable if 100,000 of the new immigrants coming to the city live within 10 kilometers or 5 kilometers of the station. Then we should probably say, okay, well in that case, we're gonna need land use ordinances and partnerships with developers and information, communications and services to make this supportive for immigrants. And we can think about what we'll need to make that happen, as opposed to just saying, well, it's too complicated, we're not gonna pay attention to that, because these I think are really the most complicated things that we build. And if we simplify it too much, then I think even if we would have nice Monte Carlo uncertainty, we'd mostly have thrown out a lot of the problem.
So this dilemma, and actually the first time I met you, I think we talked about urban metabolism and bigger scales than the typical LCA. And one of the things we've kind of been trying to look at, we wrote a framework for looking at a complete street, building in and active transportation. And we proposed in the framework that it be looked at in two ways. One is just that project, and you touched on this, just that project, the Toronto bike lanes, just that project, and then reanalyze it for that project. If that project is a part of a plan for a built-out network, then what's the impact of the built-out network projecting forward? If that's the choice that you're making, and because it's always hard to start it until you start to connect it up. It's never going to pan out. Any of that kind of building into the, that looking both at the local, the first decision scale, but do you have a plan and how does this fit into the bigger scale? Do you think that potentially improves some of the ability we're trying to figure out how to make LCA work, or at least LCA principles have bigger principles, because I don't know what's the other thing that we're going to go to. That's why we're kind of, how do we make it better? Well, maybe there's another complete tool that figure it out. But
I would argue there isn't.
Yeah.
There isn't another complete
So that's
tool.
kind of where we're at.
I think what we need is life cycle thinking. I don't think we necessarily need life cycle assessment.
Yeah, we actually trademarked lifecycle thinking.
Did you?
No, but it's actually called out. We have a Federal Highways bulletin called Lifecycle Thinking.
Yeah.
That's trying to deal with that issue.
So I think the culture and the training of life cycle assessment is really, really useful. While I don't necessarily think the tool is useful for these problems.
Right. The rules are too.
They're too narrow, and a lot of the frameworks that have tried to build into life cycle assessment for infrastructure end up with like in the European standards, it's called column D. And there's like everything else that's important in column D, because we know there's other stuff, but it doesn't fit into any of our standard life stages. So we're just gonna say there's another one, but then of course, you're left with all of the questions. You have this very specific prescribed tool, and they said, and all the other stuff. So yes, I think that developing a habit of analyzing a project on its own metrics, merits, as well as if it was part of a network, especially for things that are early days, like the first complete street or the first subway or whatever the thing is really important, because we tend to see only what we see. So if you build the first bike lane, I haven't been to Houston, but if you build the first bike lane in Houston and nobody rides it, everyone says, oh, that bike lane was a waste of money and a waste of space, and we should just bring back the car parking. Detroit recently built a little bit of light rail downtown, but almost nobody takes it, and it's losing a lot more money than they expected. But it's only downtown, it doesn't go anywhere. It's mostly geared towards tourists. the people who live in the city, it doesn't serve them. But the experience many people are seeing is that light rail in Detroit is failing. And they're not thinking about the fact that it doesn't really go anywhere, that it's too small. So if you could say, well, okay, if we built another 50 kilometers of light rail, how much would this value be of this first one? You'd probably come to really different assessments. I don't know if it would solve the problem, but I agree with you. I think that sounds like a good beginning.
I had one follow-up question, philosophical question.
Okay.
Or no, it's an implementation question. So you kind of contrasted engineers with your hubris. California, we got more hubris than anybody else. and planners. And you talked about the ICE tool, and I actually got called in to a meeting, and I thought I was just going to be a voice in the meeting, and I said, you know, we have some critiques of ICE. Who's going to voice those? And they said, John, that's why we invited you. Oh, but in that meeting, very eye-opening, and we actually had these trust-building relationships. 90% of the meeting, Federal Highways meeting with state DOTs, was trust-building between planners and engineers, which there's very little trust. And at the end, I kind of realized that as engineers, we need to take a step back, and we want to deal with numbers, but we have to look, because we like to deal with numbers, kind of following up on that question, we like to deal with things that are easy to quantify, and we really have to take that step back to larger scale. And I thought going into this that we could explain the numbers to the planners. And to be honest, one of the planners at the end of that, and this kind of felt this ripple of yeah, please stop talking to me about numbers. Just tell me what I'm supposed to do, and I'll figure out how to bring that into my planning. And that was kind of like hit a brick wall for me. Like, if I can't help you feel trustful about the numbers and the process of the numbers, then you're potentially going to believe any numbers that, how do we overcome that? So my question is, I'm thinking you're talking about dealing with planners. How do we sort out that communication and thinking? How do we provide value into their processes without overwhelming with the things that we like to do in terms of the quantification?
So the paper that I recommended for the first question about Tribus from the 70s, I think does a very good job of diagnosing the engineer's inability to communicate. And certainly I read it and was like, oh, yup. And one of the things it says that engineers do is we present all the facts and then we stop talking. And we expect that given all of the facts, everybody will draw the same conclusions we drew from the facts because it's obvious. And you can see this in the climate change debate, right? There's been decades and decades of the scientists saying, we're going to this much greenhouse gas intensity, and then stop talking, right? Or we're gonna have 2 degrees of climate change or 3 degrees of change, and then stop talking. We need to be willing to take this step after that and say, here's all of our evidence, here's the conclusion we came to, and these are the recommended actions that we need to take. And I think engineers both shy away from it because of our training. We also think that, again, it's obvious that everyone will come to the same conclusion we do. It's our style of argument. But I think also we're afraid of being inexact, of saying, well, we knew there was uncertainty and you could do A and you could do B, and we really don't want the buck to sit with us. We wanted to do the analysis, we want someone else to make the decision. I think we need to take, this may not be you, but I think our field, I think we have to stand up a little bit more to say, these are the conclusions we drew from all of our numbers, and these are the actions that we recommend.
So I agree, tried to do that. The question is there a similar paper for planners? Seriously.
Yeah, I'm sorry, why don't I take both questions at the same time?
Go ahead.
No, that was my question.
Yeah.
So I was just like wondering, like, suppose if an area is like really resource poor, like where like building an infrastructure, like it's like importation of all those like raw materials and all those stuff, where the building of the infrastructure can have like positive economic spillovers as well to the society as a whole. So in that case, like how do you assess whether those infrastructures should be built based on the life cycle cost analysis?
So I would argue that building things for short-term economic gain has blown up in our face a lot of times. And think about all of the housing we built because it was productive to keep people employed in housing construction, in Spain, here, in many places in the world. I think we need to be careful about the enthusiasm for this season's construction jobs compared to the long-term societal cost of maintaining, supporting that infrastructure and the impacts that are with it. I'm not dismissing the importance of investment in infrastructure as a driver of the economy. I think that one of the things during the recession we certainly could have done more of, but shovels in the ground just to have shovels in the ground for the wrong reason, I think we can be more directive about what we think about. If a place doesn't have very many resources, then they should build the things that are cheaper and more effective. I mean, part of the reason there's so much biking in Northern Europe is that after World War II, they didn't have very much money. And they thought, okay, well, what infrastructure can we build? Well, we can build bike infrastructure and build our cities around it. And that's by no means the whole story, but it had a big part of why that part of the world went on such a different path than other parts of the world. So it's very easy to fall back into defaults of what we did historically. And also, we have economic lessons that are very old. Right? The first highway to connect Boston and New York did massive things for economics, for trade, for access between those two places. Right? The first time you can get from A to B, you've never been able to do before. You have a big step change. The 56th time, you don't. And in most of the high-income worlds, that's what we're talking about. We have enough roads, we have enough connections between A and B. Our problem is that we've misallocated a lot of our resources.
Great presentation. It will take me much more time to kind of digest it, so my question will be probably half-baked right now, or my comment. And I really like, you know, the fact that you go back into a lot of the history of that. And if we go even earlier, there's a lot of discussion on the 50s on the systematic approach. And that was kind of LCA without the type version, which was more the region. But then the planners were coming and saying, well, you have no vision. And vision is a more like a top-down, we want to get there, and over the years, we need to start going there. While this LCA and the systematic approach is more comparing between scenarios and comparing and solving problems. So it's a bottom up. We have a problem, we solve it. We have another problem, we solve it, and we go up. So I think that that's probably where the planners and the engineers, they start from both ends and they never meet in the middle. But my question is, okay, in order for the LCA to be useful for the planners, it needs to be much more contained. And then what's the value of not doing it as a comparison? So you come and say the city, you know, GAG or LCA is based on all of our assumptions, these are the numbers. But that's a lot of assumptions back and forth, and we don't have a second option or a third option to compare to. So maybe the best way is to ask them for the vision and to compare different ways to get there. So not to do a standalone analysis, but to do a comparison analysis.
I agree.
Okay.
Yeah, I mean, I think, you know, so I started with what is my group trying to do? The whole research program I run is, are we building things that align with our long-term goals? You need the long-term goals to check if you're aligning with them. Long-term goals are hard to come up with. So in my research, I more or less define them, right? I care about the environment. And so I have long-term goals that drive my research program about reducing greenhouse gas emissions, about air quality, about sustainable resource use. And that's a lot of the long-term goals that I'm going for. But one could have and long-term goals about equity, about access, about quality of infrastructure, about stability. But yeah, I mean, I don't think you can aim for anything without having something to aim for. I think we could ask the planners for that. I think we could also have a vision. But I think there is a separate conversation that has to be had about, well, what are we trying to achieve? And that in itself is a whole other kind of long-term problem, because our governments are not set up to try and achieve long-term things. They're trying to deliver within 4 years. But as a society or as thinkers, I think we can have that conversation.
Thank you for your nice presentation. My question is about these topics as well, about eyes that you, it was the only tool that I saw, and I want to know in Canada you have developed any other tools or you followed FHWA. I have no idea about policy and planning that you follow in Canada. I want to know.
For life cycle assessment?
Mhm.
Yes, I mean, we have tools, and we more recently have policies. So one of the policies I put out from Canada is called the Climate Lens Policy, and it requires for certain amounts of funding, if you want funding through a particular government program, you have to put a climate lens on any infrastructure investment. And then if you do that, you can have the money. There's also a resiliency lens that comes with it. There's a couple different tools that you can use. One of the approved tools is Envision, the infrastructure rating system. You can also use ISO standard lifecycle assessment. The specific tools for resilience are escaping me. Most of the Canadian thinking about lifecycle assessment and the tools have come out of, this is embarrassing. Out of a group we have, whose name I can't remember.
Athena?
Thank you. Out of Athena. And they have publicly available tools. They used to keep one updated publicly that was for infrastructure, but now it's mostly, at least the publicly available one is updated for vertical construction. They also are still the biggest outputter of LCI data in Canada, but our federal government is at the early stages of the initiative to do a national scale LCI, which I think we would desperately need if we wanted to do embodied carbon assessment, life cycle assessment
And any of
in more
these,
detail.
any of these tools include social indicators or just environmental indicators?
So those include, those are all fairly narrow life cycle assessment tools. We do have social assessment frameworks like everyone else. We've recently had a change of the way we do environmental assessment, which is supposed to include more sustainability assessment. We also have a very strong federal mandate to consult with Indigenous communities, which I think would be our strongest social mandate, which is court ordered and very much in flux in Canada, and what that looks like and how you do it well, nobody knows yet. The conversation about Canadian relationship with Indigenous communities is one of the biggest national policy issues in Canada at the moment, and it plays into a lot of our infrastructure, especially oil and gas. But I'm not an expert, so I'm going to stop talking about that there.
On your second slide, you saw like 10 projects that was over like $3 billion in total, $3 billion or whatever. So is there a benchmark like with you perform LCA analysis, and under those like benchmark, is there a way that you do not have to perform any LCA? Because on the slide that you showed, all the projects were like $3 billion.
Well, those are all the big ones, right? We started at the top and we're working our way down.
So is there a benchmark like where we don't have to like perform LCA?
You mean, do I or does the government?
Either one.
So no, because you don't have to ask for federal money if you don't want it. So you don't have to. It's not a requirement. It's a carrot. We've got carrots rather than sticks at the moment. For environmental assessment, so not necessarily LCA, but environmental assessment, it really depends on the project. There's both federal mandates for when you have to do environmental assessment and provincial mandates for when you have to do environmental assessment. And both of them have recently been rewritten. There were announcements last week, or I guess this week, about changes to the provincial assessment. So it's all a little bit all over the place. And that's not usually based on monetary, but based on type of project and scale of project. If you're doing anything of national importance, you got to do federal. If you're crossing boundaries, you got to do federal. If it's federal jurisdiction, you got to do federal. If it's anything the province is doing, they've got to do provincial one. So it depends, and it changes from province to province.
That reminds me of the like cartoon that you showed where like what people want is very different than what it is conceived earlier. So there's like extra overhead cost in all those group projects with all these steps that you are involved in.
I'm sorry, can you repeat that? The truck drove by.
So I mean, like I was just like thinking, like whatever you showed on the slide about the the cartoon picture, like where the need of the people is like very different than what is like conceived in the planning process. So having all these like steps in the planning process might add like overhead cost to the project that we are gonna implement or build.
Yeah, I mean, there's a lot of arguments about which is more cost-effective, centralized planning, dispersed planning. People tend to find both unsatisfactory. So you do a lot of dispersed planning and say this doesn't work, and so you pendulum into centralized planning and say this doesn't work, and so you pendulum back to dispersed planning. I think the answer is these things are just hard. And they're complex and they last a long time, and many of our incentive structures are just not well aligned with infrastructure. When I give this presentation in Canada, I have a meme up which says, be like Eglinton, focus only on yourself with not caring about what happens to other people. And what's that about? It's a subway construction project on a street called Eglinton that's been going on for 10 years. And people are mad. They've lived near a construction site for 10 years, businesses have shut down, it's been noisy, traffic has been bad. And so this meme went around to great popularity of people being like, oh, I'm so mad at Eglinton. But they totally lost sight of this is one of the biggest construction projects in the country that will fundamentally change the way the middle of our city works, which will increase the carrying capacity of that part of the city by more than 150,000 people, right? This is not about Eglinton being selfish. It just takes time to build stuff, right? It's like if you ever renovated your bathroom, it sucks that you can't poop at home for a while, but then you have a new bathroom. And we're not very good at having that perspective at city or national scale infrastructure. And also there's a mismatch in between who experiences disbenefit and who experiences benefit. And if you're a business owner right beside the construction project, you're going to experience a lot of disbenefit for a very long time. But if you live 300 meters away or 500 meters away in an apartment and we used to take 2 buses to work, as soon as the project opens, you're going to experience a huge benefit, as are people who live even farther afield. So I think part of the challenge with infrastructure is there's a big mismatch between infrastructure time and human time, and it's very hard to sort that out. I think it makes us pretty bad about thinking of these type of problems as humans.
Let's go ahead and we have one last question.
I know somebody has to ask one.
Well, we're up against our. All right, well, thank you.